If you took a DNA test tomorrow and it told you that your closest living genetic cousins were not who your government, your textbooks, or even your own family had always told you, would you believe the science? Or would you reject it? Because that is exactly the question sitting underneath one of the most quietly explosive debates in modern genetics. Who, out of every population alive on Earth today, carries the DNA that sits closest to the indigenous peoples of the Americas? Is it the Mexican farmer whose grandmother spoke Nahuatl? Is it a reindeer herder in Siberia who has never heard the word Native American in his life? Or is it someone else entirely, a population so small, so remote, that most textbooks forget they exist at all? By the end of this video, you will know the honest, evidence-based answer. And it is not the answer most people expect. Every year, millions of people spit into a tube and mail it off, hoping to find out who they really are. And for people across Latin America, especially Mexico, that question carries enormous emotional weight, because indigenous ancestry there was never fully erased. It survived in bloodlines, even when it was suppressed in history books. But here's the uncomfortable truth. Popular culture has trained us to think of closeness in DNA, the way we think of closeness in a family photo who looks most alike. Real population genetics does not work that way. It works through timelines, migrations, and the slow drift of shared ancestry across thousands of generations. And that timeline starts in a place most people never think to look: the frozen plains of Siberia, more than 20,000 years ago. Around the peak of the last ice age, sea levels dropped so low that a vast landmass connecting Siberia to Alaska emerged from beneath the ocean. Scientists call it Beringia. It wasn't a narrow bridge, it was an entire subcontinent of grassland, wide enough that some populations lived there, isolated, for thousands of years before ever moving further into the Americas. Geneticists now believe this isolation is the key to everything. A population descended from ancient North Eurasian and East Asian ancestors became genetically distinct while trapped on this land, cut off from both Siberia to the west and the unglaciated Americas to the south. When the ice finally retreated, their descendants moved south and became the ancestral founders of every indigenous nation from Alaska to Patagonia. This single population bottleneck is why, genetically speaking, all indigenous peoples of the Americas, from the Inuit to the Mapuche, share a deep common ancestry that no other population on Earth fully replicates. In 2013, scientists extracted DNA from the 24,000-year-old remains of a young boy found near Malta in south-central Siberia. What they found rewrote the textbooks. Roughly a third of this boy's ancestry showed up, almost unchanged, in the DNA of indigenous peoples across the entire Western Hemisphere. This population, now called the Ancient North Eurasians, did not simply vanish. Their genetic signature survives today, most strongly in a small number of Siberian ethnic groups, including the Ket people of the Yenisei River and certain Chukchi and Koryak communities of far eastern Siberia. These are not large, famous nations. Most people have never heard their names. And yet, on a pure genetic distance basis, several of these small Siberian populations sit closer to Indigenous American ancestry than any large modern nation, including China, Japan, Korea, or Mexico. That's the twist very few documentaries are willing to say out loud. So where does that leave Mexico? Here is where nuance matters most. Modern Mexicans are not a single genetic population. They are the product of centuries of admixture between Indigenous American peoples, European colonizers, and, in coastal regions, West and Central African ancestry. Studies of Mexican genomes show Indigenous American ancestry ranging anywhere from roughly 30% in some urban mestizo populations to over 90% in indigenous communities in Oaxaca, Chiapas, and the Yucatan, who never fully assimilated into colonial mixing. This means the real answer is not Mexicans. As a single block, it is specific indigenous nations within Mexico, such as the Zapotec, Maya, and Purepecha, who carry direct, unbroken lineage back to those original Beringian founder populations. Genetically, an unmixed Maya or Zapotec individual carries a purer, more concentrated version of that ancient American founder DNA than the average person who simply identifies as Mexican on a census form. So the popular idea that Mexicans are closest to Native Americans is true, but only when we're precise about which Mexicans we mean. Now, what about Asia broadly, China, Japan, Korea, Mongolia? Here's the honest science. Yes, there is a real and deep genetic relationship. East Asian and Indigenous American populations share a common ancestral root going back tens of thousands of years. And certain Y chromosome and mitochondrial lineages, like haplogroups A, B, C, and D, appear in both East Asian and Indigenous American populations. But related is not the same as closest. Mainland East Asian populations diverged from the ancestors of Indigenous Americans tens of thousands of years before the Beringian population itself formed. In genetic terms, that's an enormous amount of separation, enough that modern Han Chinese, Japanese, or Korean populations are genetically more distant from Native Americans than those small, often overlooked Siberian groups sitting right at the doorway of Beringia. In other words, geographically, Asia is the right continent. Genetically, it's often the wrong population. So, after tracing 20,000 years of migration, ice and DNA, here is the honest verdict. The single closest living genetic relatives to Indigenous Americans, on a population distance basis, are small Siberian groups like the Ket and certain Chukotko-Kamchatkan peoples, the living echo of the ancient North Eurasians. The closest large self-identifying population with deep, unbroken cultural and genetic continuity is not Mexicans as a nationality, but specific unmixed indigenous nations within Mexico and across Latin America, the Maya, Zapotec, Quechua, and others who carry the most concentrated surviving founder DNA. And broad East Asian populations, while genuinely related through deep ancestry, are the most genetically distant of the three groups people usually debate. The uncomfortable truth is this: the closest DNA match isn't a country. It's not a flag. It's specific peoples, many of whom have been ignored, displaced, or erased from the very history that their DNA helped write. DNA doesn't erase culture, and it doesn't replace identity. A person's history, language, and lived experience matter just as much as what a lab report says about their genome. But science does something powerful. It reminds us that the boundaries we draw between us and them are often far younger and far thinner than the deep human story running underneath them. 20,000 years ago, a small group of people survived an ice age on a strip of frozen land that no longer exists, and every indigenous nation across 2 continents, along with a handful of forgotten Siberian communities, still carries their signature today. So the next time someone asks who is genetically closest to Native Americans, you'll know the real answer isn't the one on the map. It's the one written in blood, ice, and 20,000 years of survival. If this changed how you see ancestry, DNA, and identity, subscribe, and I'll see you in the next one.